All right, today we're going to be looking at section 5.1, transformations of functions. I'm going to point through the learn, and I've also handwritten some notes here. We're going to be looking at equations, and they'll be in different forms, and we need to identify the A, the B, the H, and the K, and each of those will tell us how the graph will be shifted or transformed from the original or the parent. So here I'm just showing you that K will shift the graph vertically, so that means it's going to go up or down. If it's positive, it goes up, and negative, it goes down. It does exactly what you think. I would definitely recommend that you take time, pause the video, and definitely get these written down. I want to do it beforehand just to save a little time. All right, and then the H. So what you'll notice, the things in parentheses with B, this is the way I train myself to learn it. The things in parentheses with B, with X, I'm sorry. The things in parentheses with X, they are going to do the opposite of what you think, based on what you see visually. So H is going to shift the graph horizontally, so left and right. So if you see a positive value here, it's going to go left. And if you see negative, it's going to go right. So it does the opposite of what you think as far as the x-axis is concerned. And then the B, the number in front of X. Now, how do you know the difference between B and A? Well, you will specifically see some kind of grouping symbol, whether it be parentheses, a fraction bar, a square root symbol, an absolute value symbol, some kind of grouping symbol that clearly shows that it is in a group with B. So just because it's right in front of X doesn't mean it's the B value. Sometimes it could be the A value. Unless you see like a grouping symbol specifically letting you know that it's B. Otherwise, you're going to default to whatever that is being A. So that is also something that you kind of got to pick up as you go. But what B does is it will horizontally stretch or compress your graph in the horizontal direction. So going long ways, it will stretch it out or push it, squeeze it together. And so here's how you know. You're going to look at the value of B, or the distance from 0, really. So that's what we do when we say absolute value. How far is that number from 0? So it doesn't matter if it's negative or positive. We're looking at the distance. So if this number is bigger than 1, it could be 1, 2, 3, 4, 5. It can't be 1, so it has to be bigger than 1. It could be 1.1 or bigger. Or it could be negative 1.1 or smaller in the negative direction. It could be negative 2, negative 3, negative 4. The absolute value will make it positive, so you'd be looking at the distance from 0. So if this number B is more than one space away from 0, you will have a horizontal compression. And if that number is less than one space from 0, so between 0 and 1, like a half or a fourth or a third, or it'll be 0.67, something like that. So it's less than 1, but greater than 0, the absolute value of it is going to be a horizontal stretch. And then if B is negative, okay, that will flip it across the y-axis. So you have a y-axis reflection. So this is important to have. And then part 4, this is the last transformation we'll be looking at, the A, the one out front. And it will vertically stretch or compress your graph. It's a vertical stretch or compression in almost the same parameters as B. If you look at the absolute value, the distance that number is from 0, if it's more than 1 away, it will vertical stretch. Okay, exactly what you think. The bigger it is, the more it stretches it out. And then if it's between 0 and 1, the smaller it's going to compress it, make it shrink. And then if A is negative, you're going to flip across the x-axis. So these are the handwritten notes. I like these a little bit better because it kind of points you into the value of that number. Because if I say just greater than 1, you would think it would compress it. And if I said less than 1, like meaning negative numbers, you would tend to think it would horizontal stretch. But it's not necessarily the negative or the positive. It's the number itself when you look at the absolute value. So I don't think the notes go that great into detail, but I will kind of explain why this does the opposite. So the horizontal shifting is explained here. You see how the formula has a minus in there. So when you plug a negative number would tend to go left, but when you plug a negative number here, minus a negative, it becomes positive. So visually what you see a positive number, and that's why we say positive goes left, when really you actually plugged in a negative number. And they explained that, let me go a little bit more right here. They're kind of showing you that, okay, if you plug in a negative number, minus a negative is going to look like plus. And that's why it's actually going left when you see a positive. And then when you see a negative, it's going right because you plugged in a positive number there, and then it made it negative. So it kind of shows you these things here, right here, as far as transforming the graph. And they give you very, very good notes. Now, also, I'm going to go ahead and exit out of here. You can kind of go through all of them, but it shows you each of the things we just mentioned, as far as changing over the X and Y axis. If it's negative out front, we just kind of talked about that. But let me just continue to go through. So here's the A button. They're showing you that. See, they don't put it in absolute value, and that's the thing that I think is important, because you could have a negative 1/2, and a negative 1/2 is going to compress it, and this is going to flip it. Or you can have a negative 2. A negative 2 is going to stretch it, but it'll just flip it. So I think the definition is kind of lacking in that area. So I like it for you to write it this way. And then you got several examples that they go through and showing you some visuals. And then here are them describing the stretching and compression, but they use the letter A instead of B, which I don't like that either. I like to see a different letter so you can be sure of what's going on. And then here's the order of transformation. So this is important. You're going to do the shift first. So it's kind of like doing the order of operations. You're going to work inside out. Okay, so you're going to shift first, and then you're going to do the horizontal stretch and compression. So you're going to take care of that. So this and then this, and then reflection. So after you shift and do this, then you're going to reflect if this has a reflection, and then you're going to reflect this one if it has a reflection, and then you're going to shift that one last at the back. Okay, so that is the order, and that's very important to note, because depending on when you have some of those reflections, if you shift, let's say right, and then you reflect across the y-axis because this is negative, it's going to look like you actually shifted your graph left. And we may see an example like that when we begin to solve them. Okay. So one more thing I want to show you, that all of this I have added prior in your course. So I believe we did that in module 2. Yes, so we got parent functions. The big thing that you need to be aware of are, I'm going to go to the parent functions plus. The big thing you need to be aware of are the parent functions, the original graphs. Let me make this a little bit bigger. You need to know what constant functions look like, what linear or identity, quadratic or square, because we're going to be transforming these, and you're going to have to tell me how is the new graph going to be different from the original. Now, also at the very bottom, so this is the last page, but the box above it, this is also explaining the transformations. Tell you K moves up or down, H moves up to right. However, it says positive moves right, and that is opposite of what I have written. I told you in the notes here that positive moves left because of what you're going to see visually. But they're telling you based on the number that you plugged in. So be careful with that. That's the difference there. And the textbook does kind of explain why. And then you have A is the vertical stretch or compression. It shows you B, and then it shows you a negative A and negative B, that it flips, and it gives you the function notation. And then we won't see any angle rotation, so don't worry about that last part. But this is also just another description that's already there for you in Blackboard in your content folder in Module 2. Okay, so without further ado, we're going to go ahead and jump into Hawks and begin working some examples. So do take time and write this down. The nice thing about this section is you don't have to do a whole lot of calculations, but you do need to be able to refer back to this and understand how your graph is going to change. And it will take a little bit of time with the different functions identifying what number is A, what number is B, what number is H, and what number is K. But once you identify those, it's very straightforward as far as what's going to happen to your graph. Okay.